These are the notes for section 9.8. You should have your textbooks open to page 578. And in 9.7 at the very end, we started talking about something called a geometric ratio or a common ratio for those exponential functions. And basically, we're going to take that and we're going to move into something called a geometric sequence, and that's just a type of exponential function. So, a geometric sequence is a sequence whose first term is non-zero, and each term after the first is found by being multiplied by the term, by the previous term being multiplied by a non-zero constant. We're going to call it r, and that is called our common ratio. So our common ratio's definition is a non-zero constant, r, used to find the terms in a geometric sequence. We've already done this. I'm just going to show you how to find them for a specific sequence. If you remember back to, I believe it was 9.6, we had those tables. Look on page 569. It gave us tables of x and y values and said identify the exponential behavior, and we had to decide if it was an exponential function, and if it had a common ratio, then it did, or it was an exponential function. If it wasn't, then it was not. That's basically what we're going to do today. So take a look. It says determine whether each sequence is a geometric or arithmetic, geometric, or neither. So arithmetic is adding or subtracting, geometric is multiplying, and neither means that there's no pattern. So you can find out by dividing terms by the previous term. So, for example, I have 128 and 256. So from here to here, I'm going to say 128 over 256. Let's type that in the calculator. And I get 0.5. So the geometric ratio, or if it were geometric, it'd be 1/2, multiplied by 1/2. Now let's take 128 times 0.5. I get 64. So that worked. And then 64 times 1/2 gives me 32. So I can see that I multiply by 1/2 for each term. So this is a geometric sequence. Now let's take a look here. I go from 4 to 9, so if I take 9 over 4, I get 2.25. If I take 12 over 9, I get 1.33. So this one is not geometric, but let's see if I can add anything to make that happen. If I add 5 here, then I add 5 here, I would have gotten 9, 14, so that doesn't work. So this is neither, because I can't add anything to each term to get the next number, and I can't multiply by anything to get the next number. Turn to the next page. This one tells you these are geometric sequences, and it asks you to find the next 3 terms. First thing you have to do is decide what's being multiplied here. This one's pretty easy. I know to get from 1 to -4, I multiply by -4. Same thing to get from -4 to 16, and then from 16 to -64. So my ratio is times -4. So keep going. I take -64 times -4, and I get positive 256. Multiply that by -4, I get negative 1024. Multiply that by -4, and I get 4096. Okay, let's do this one. I know I'm going from 9 to 3, which gives me times 1/3. 3 to 1 is times 1/3, and so is 1 times 1/3. So the next ones will be 1/3 times 1/3, which is 1/9. The next one is 1/9 times 1/3, which gives me 1/27. And 1/27 times 1/3 gives me 1/81. Okay? So it's as easy as that. You just have to identify the common ratio and then multiply it to consecutive terms in order to get the next ones. Now, we can also write a general equation for a specific geometric sequence using a sub 1, where a sub 1 is the first term, so like 1 here or 9 here. R is the common ratio, so -4 or 1/3, and N is the term you are looking for. So it says a sub 1 r to the n minus 1 power. So if I was looking for the ninth term of the sequence starting with -6 and a common ratio of -2, I'd just start plugging those things in. The first term is -6, common ratio is -2, and I'm taking the ninth term, so n minus 1 gives me 8, so 9 minus 1 gives me 8, so I take -6 times -2 to the 8th power. -2 to the 8th power, I'm just going to type it in my calculator, but remember I'm dealing with negatives, so it has to go in parentheses, gives me positive 256, and then I take -6 times positive 256, and it gives me negative 1536. So it's as easy as that. If we turn the page, we're going to start writing those equations and then find the terms. So write an equation for the nth term of the geometric sequence, 96, 48, 24, 12, and then find the 10th term of the sequence. So my equation's going to go a sub 1 times, flip back, r to the n minus 1. So a sub 1 was 96 times r, which we have to find our ratio yet. So we have 48 over 96, which is 0.5. So I know that my ratio is 1/2 to the n minus 1. Now we're finding the 10th term, so 10 minus 1. So I have 96 times 1/2 to the 9th power. Let's type that in. I'm going to type it in my calculator, and I'm going to say 96 parenthesis 1/2 to the 9th power. And I get 0.1875. And let's double check that. I think that might be as hard as it gets. Okay. So let's move on to the next one. I go from, I need to double check this. Okay. I will accept your decimal answers, but if you can find it in a fraction, that would be great. In this case, this would be 3/16. So now I'm going to take this one, and my common ratio is -24 over -6, which gives me +4. And my equation will be a sub 1, so -6 times r, which is 4, to the nth power, which is 5 minus 1. So I get -6 times 4 to the 4th power. Let's type that in. -6 times 4 to the 4th power, and I get negative 1536. And that's as easy as it gets. So all you have to do is plug in the numbers that they give you. You have to find that common ratio, plug in the numbers that they give you to this equation, and then type it into your calculator. That's the end of the notes. Let me know if you have any questions.